Angela, I'm going to pass things over to you to introduce today's webinar.
Great, thanks Sarah. Hi everyone, I'm Angela Robinson and I'm a member of SPSSI's Graduate Student Committee. Sarah, you can go to the next slide. I just wanted to give a quick introduction to SPSSI for those who are unfamiliar. So SPSSI was founded in 1936 and has grown to a group of over 3,000 scientists and researchers who share a common interest in research on the psychological aspects of important social and policy issues. As an organization, we aim to bring theory and practice into focus on human problems of the group, the community, and nations, as well as issues that have no national boundaries. SPSSI is an independent society and is also Division 9 of the American Psychological Association and an organizational affiliate of the American Psychological Society. We welcome the membership of anyone who's interested in joining the society, and you can visit spssi.org, that's SPSSI.org, for more information or to become a member. Next slide. As an organization, SPSSI offers its members a wide variety of opportunities. In addition to offering an intellectual home, networking opportunities, conference collaborations, awards, and fellowships, we also have a peer mentoring program, a policy and methodology webinar series, writing opportunities in our graduate student newsletter, and more. These projects aim to support graduate students and faculty in their scholarly and policy-related pursuits. If you'd like to learn more, our social media outlets are also a great place to get more information about SPSSI and the opportunities that we offer our members. Next slide. And with that, I will introduce today's speaker and we can jump right into it. So today we're welcoming Robert Marx, who is a Ph.D. student at Vanderbilt University. Robert's a former high school English teacher, and his research focuses on youth and adolescent development, especially the ways queer youth in high schools thrive in their heterosexist school systems. His work has taken many forms, including qualitative focus groups and propensity score matching data from standardized tests, but he's especially interested in meta-analysis and the quantitative synthesis of primary research. These techniques can help policymakers and practitioners make decisions based on the best possible information. We'll be hearing more about that from him today. Outside of school, Robert is also an adult advisor for a queer youth group, a volunteer for a program that brings youth involved in the juvenile justice system together with dogs, and he's the father of the world's cutest poodle mix, Poppy. So with that, I'd like to give a very warm welcome to Robert on behalf of the SPSSI Graduate Student Committee. Thanks for sharing your knowledge with us today, and I'll turn it over to you.
Thank you so much, Angela and Sarah, and thank you to SPSSI for hosting me. I would just like to give a brief overview. Today I'm going to be talking about an introduction to systematic review and to meta-analysis. And I just want to clear up for whom this webinar is dedicated and for whom this webinar is probably not appropriate. If you've already taken a meta-analysis class and you're interested in talking about the dispersion of tau squared, please send me an email. I would love to talk with you about that, but this meta-analysis workshop is not for you. If you already have some expertise with meta-analysis, I urge you to close your computer, turn on the TV, watch a rerun of The Office, or do something that is otherwise fulfilling to you. However, if you don't know a ton about systematic reviews and meta-analyses, and you're hoping to learn more, I hope that this webinar provides you with an overview of both how one goes through a systematic review and meta-analysis and why it might be useful to you and to the world. I do want to quickly say that in my work, I try to hold a social justice commitment, and I think in our ever-changing society where evidence is becoming even more important every single day, I would hope that we work to push for the gold standard of evidentiary support for all decisions that we make, and I hope that my meta-analyses and potentially your future meta-analyses work to push that forward. Could we progress to the next slide, please? So I'm just going to give you a brief agenda. I'm going to overview some key terminology and definitions. I'll talk about the practical importance of systematic reviews and meta-analyses. We'll talk about the limitations, and then I'll walk you through step-by-step how one would conduct a systematic review and meta-analysis. I'll close with giving you some useful resources and then taking some questions. I'd also like to formally, very gratefully acknowledge Dr. Emily Tanner-Smith, who was a professor at Vanderbilt and who will soon be a professor at the University of Oregon, for her help as she taught the course in meta-analysis that I've taken, and she's also been an excellent mentor for me. Next slide, please. Next slide, please. So when we talk about reviews, most of us feel like we've probably done one. I know I certainly have. And when I think about a review, I often think about finding resources that support what I already believe. So if I'm writing a paper about gay-straight alliances and victimization, and I'm writing a review to start my paper, normally what I would do, if we're being completely honest, is I would go into Google Scholar, I would type in gay-straight alliances and victimizations, and I would find some articles. I'd look at the titles and see which of those titles corresponded to my beliefs. I'd pull up one that seemed particularly good. I'd read the abstract, make sure it agreed with what I wanted. Then I'd skim the paper, and I'd use it in the citation of my review. We all do this, and for some of us, it's all we do. I may have given kind of a stereotypical or exaggerated discussion of what a review might be, but if we look inside our hearts, we know that oftentimes what we do when we do a lit review is we find information that supports what we already believe. And we do it in a manner that's not particularly systematic or rigorous. This is contrasted with systematic reviews and meta-analyses. If you could get the next slide, please. So a systematic review is transparent and replicable. Those two words are super important. It's transparent, meaning that every decision that's made can be seen and is explicit. And it's important that it's replicable. What that means is that if someone else picked up my meta-analysis, they should be able to follow my exact steps and get my exact results. Our interpretation may vary, certainly, but I should be so upfront and so transparent with the choices that I make that anyone could reproduce it. We hit the next slide. A meta-analysis is the quantitative synthesis of results from multiple research studies. So a systematic review is the compilation of prior research done in a transparent and replicable way. Meta-analysis involves the quantitative synthesis of those studies from a systematic review. Now, all systematic reviews do not culminate in meta-analyses, and all meta-analyses do not grow out of systematic reviews. But I think it's most useful to think about the fact that a systematic review should form the basis for a meta-analysis, and that we should conduct meta-analyses if they are possible. Next slide. The other term that I'll use fairly frequently is effect size. The effect size is the outcome of interest in a meta-analysis. Because a meta-analysis represents the synthesis of many different research studies, we use effect sizes to standardize sometimes disparate findings onto a common scale. So for example, if we're looking at GSAs and victimization, we may find 8 different studies that operationalized and measured victimization in 8 different ways. In order to synthesize them, we would need to put them on a standard metric so that we could combine them in a meaningful way. And effect sizes are one way that we do that. We have effect sizes for associations, like Pearson's R or correlation. And then we also have effect sizes for group differences. So we could see differences in means, or we could see differences in odds or risk ratios. Next slide, please. Now, systematic reviews and meta-analyses are important because they offer us the opportunity to combine multiple studies that provides a more complete answer to any one question. So for example, if we wanted to know about GSAs and victimization, we could just do our Google search and read the first article that comes up. If that article is a great article, cool. But if it's terrible or flawed or methodologically problematic, we've based a decision on incomplete evidence. Systematic reviews and meta-analyses give us the chance to have a more complete evidentiary base before we move forward. Next slide. Importantly, systematic reviews and meta-analyses are transparent and replicable, as I said, and they stipulate a priori what will and won't be included. That's very important because when we think about how we synthesize our research, we need to be clear from the front what is applicable and what is inapplicable. And that's important because we can't just pick and choose findings that support what we want. We have to be upfront from the beginning and say that we will report what we find regardless of what we find. Next slide, please. As I said, this will provide us with a comprehensive survey of all of the available literature. Next slide. And importantly, it can comment on both the outcomes and the quality of primary studies. We'll talk about this more in a bit, but meta-analyses, because it offers us a bird's eye view of many primary studies, gives us the chance to not only synthesize together the outcomes, but also to comment on the methodology of a primary study. We will see that we can evaluate primary studies' risk of bias or quality to get a better sense of how strong our evidentiary base is. Next slide. I think it's important to be upfront that meta-analyses are not a panacea. They are not a cure-all. They are not the most perfect thing in the world. They do have limitations. The strongest limitation, I think, is that they're only as good as the primary studies that they synthesize. We call that garbage in, garbage out. If I take 40 terrible studies and somehow manage to synthesize them together and get an outcome, while that will be a complete meta-analysis, the findings may not be particularly strong, compelling, or robust. We need to be careful to make sure that we select best methodology practices for the studies that we include so that we're not just synthesizing together a bunch of junk. Further, meta-analyses can't answer all types of questions. For example, meta-analyses don't include the synthesis of non-quantitative studies. So if we have qualitative literature, we can include that in a systematic review, but we cannot include that in our meta-analysis. Moreover, we can only synthesize research that's available. So for example, in my own work, I do work on gay-straight alliances. And one of the real problems that I've run into is that there aren't any randomly controlled trials, or RCTs, of GSAs. I can only synthesize what's available to me. And then finally, it's important to note that we can use meta-analysis to synthesize unrelated or not related enough outcomes. It's important that we don't mix apples, oranges, and tomatoes together as we make our fruit salad in meta-analysis. If I am doing a meta-analysis of GSAs and victimization, it seems appropriate that I would include different measures of victimization. However, if I also included a measure of fear for safety, that seems to be a substantially separate construct from experiencing victimization. And if I mix those together and synthesize them together, which I could mathematically, of course, that would present a problem and would be a limitation. So when you're reading someone else's meta-analysis, you should be very careful to see what they operationalize and what they combined as their constructs. Next slide, please. So I'm just going to run you through kind of the 5 steps of systematic review and meta-analysis. One starts by defining his, her, or their question, then searching the available literature, extracting relevant data, analyzing that data, and then interpreting and situating the findings. Next slide. We'll start by defining the question. When we define the question, we think about what types of topics interest you. For example, for me, I'm most interested in the association between GSAs and student reports of victimization. What effect size is most appropriate? Well, in order to know what effect size I should be using, I need to know what the data exists. So if I'm working with data that is correlational, I will probably end up with an effect size that's a Pearson's R. If I'm looking at data that compares 2 different groups' scores on a measure, I will probably use a standardized mean difference, measuring student reports of victimization, for example. And then what information do I want to extract? I would want to extract the basic study data, like what year, how many authors, sample data, like how many people were in each group, what the gender and racial breakdown of each group was, and then outcome data, of course, what they actually reported or found, and finally, quality data. It's important for us to extract all of this data because it's important for us to understand the many facets of the review. We need to know, for example, if a primary study found a very strong, significant effect, but it had a very, very, very small sample size, we would want to mark that. We will want to capture that. If a study found no significant results at all, but it was marked by significant bias, it did something really, really bad, we would also want to capture that. It's important for us to capture all facets of this information as we're moving through, but it's also important that, as I said, we define a priori what will be included and what won't be included. We need to set up our topic, our effect size, and what we'll be coding in advance so that we don't have any, oh, by the way, decisions midway through that change the scope of our review or that we would be making just so that our results looked a little better. Next slide, please. When we think about defining the question, we often use the acronym of Pecos, which stands for Population, Intervention, Comparison, Outcome, and Setting. This gives us our inclusion and exclusion criteria, and it's very important that we establish these before we begin our search and before we begin our coding. we need to know what population we hope to talk about. For example, I wanted to look at students currently enrolled in high schools. That means that if I found a study of college students who were reflecting retrospectively on their experiences in high schools, that study would not be eligible and it would be excluded from my meta-analysis. I would also need to determine the intervention that I was interested in. For me, I'm interested in gay-straight alliances, so I would need to look at a primary study that had a gay-straight alliance. Now, in the actual paper that I would write about this, I would more clearly define and operationalize gay-straight alliances. I would make sure that they're distinct from diversity clubs or other groups that aren't focused explicitly on LGBTQ students. I would need to define my comparison group as well. So I need to compare students who received an intervention with students who did not receive an intervention. So in this case, that would be students at schools with GSAs compared with students at schools without GSAs. I would also want to determine at the beginning my outcome. For this narrow meta-analysis, I may want to say any measure of victimization is fine. For the broader GSA meta-analysis, I may want to say any outcome at all is fine. And I will handle that in separate meta-analyses as I move forward. What I could do in that case is I would accept any study that provided any quantitative outcome of comparing students in a GSA and students not in a GSA. And then I would just conduct separate meta-analyses for the separate outcomes. So for example, if a primary study reported on depression, and a separate primary study reported on drug use, and a third primary study reported victimization, drug use, and depression, I would code all of those outcomes, but I would only synthesize together the depression outcomes with each other, the drug use outcomes with each other, and the victimization outcomes with each other. Finally, I would want to choose setting. Many meta-analysts use the setting as a way of kind of limiting what populations and what places they'll be talking about. So at times, you will see a meta-analysis that says, well, I'm only interested in the United States, or I'm only interested in developing countries, or I'm only interested in urban spaces. For my particular meta-analysis, I was not only interested in any of those things, so it was any high school anywhere in the world. It's important, you'll see kind of almost small print at the bottom. No exclusions are made based on language, publication or peer review status, or date. This is a really important note. When we think about the ways that we do non-systematic literature reviews, oftentimes we only search Google Scholar and we only look at peer-reviewed articles. Now, there may be merits to that, certainly, but I think that anyone who has been through the peer review process knows that being peer-reviewed is no guarantee of gold quality, and moreover, not being peer-reviewed is no indication of poor quality. So many meta-analyses will include both published and unpublished literature so that we can get a more broad and comprehensive understanding. It's also important to note that the gold standard for meta-analyses places no limitation on language, meaning that a document could be published in any language. Publication or peer review status, meaning that it could be a journal publication, or it could be a government publication, or it could be a master's thesis, or it could be something that an empirical study that you just found online, or date. When we think about placing a restriction on a date, if we have a very strong reason for doing so, it might make sense. For example, the first GSAs started in the late 80s. So if I wanted to set a date of 1985 or more recent on my study, that might make sense so that I didn't get a whole bunch of junk from before 1985. But I could also just say no limitation on date and pare through what was relevant and what was irrelevant. Next slide, please. Once we've defined our question and we've made these a priori claims about what we will and will not be looking for, it's time to start looking. And what we do is we search the literature. This is super important because comprehensive searches are what we need to mitigate publication bias. We all know that when someone, for example, a news story or an undergraduate student or just a regular civilian making a decision about his, her, or their lives, goes to make a decision, they oftentimes will just search and find whatever is most easily available. Unfortunately, if we rely only on what is most easily available, we often miss other studies. So for example, it is much easier to get a journal article published if you find large significant reviews. If you don't find large statistically significant results, you are much less likely to get published. That doesn't mean that, of course, your work is any less valuable. It just means that people aren't as interested in reading about how nothing happens. The problem with that comes when we try to make claims about programming, and we only find published studies that show how much is happening. What meta-analyses offer us is the opportunity to look at both published and unpublished studies, to synthesize together both these larger effects that are more likely to get journal published and those that may not. Next slide. So we do start by searching the relevant electronic databases, ERIC, PsycInfo, any of the ProQuest searches that you would do. But it's also important that we locate what we call gray literature. Next slide, please. Gray literature can be found by hand-searching key journals, which I did. I gave you a couple of examples of the journals that I actually searched for my meta-analysis. It can also be used by forward and backward citation searching. So what we do in the meta-analysis community is we look at the articles that are eligible studies cited and articles that cited our eligible studies. So we look both forward and backward in the citation hierarchy so that we can see if there are any studies that we missed. We also look at conference proceedings so that we can get a sense of if there's any unpublished results that we haven't found. All of this is to find more comprehensive results so that we can include any study that might possibly be eligible. Next slide. Beyond this, oftentimes meta-analysts will undergo expert consultation. What I did was I just looked at the studies that were eligible, and I Googled the authors of those studies. I looked at their CVs to see if there were any additional articles that should have been included, and then I actually sent them emails saying, hi, my name is Robert Marx. I know you haven't heard of me, but I'm friendly, I promise. I am doing a meta-analysis on GSAs. I'm including your study, and I wondered if you knew of any other studies that I might not find. Here are the studies that I found. Please let me know if you know of any others. Again, we're just trying to get the most comprehensive literature base we possibly can. Finally, it's important to get gray literature by searching through trial registrations, government websites, and non-academic sources. The more sources and searches you do, the more robust your findings will be because they will include as much evidence as possible. Again, our goal here is to provide as much of a comprehensive base to do our meta-analysis as possible. So it's really important that we go out of our way to search both easily accessible and less accessible sources to find literature for our review. Next page. Now, what you see here is a sample search flowchart from my meta-analysis on GSAs and victimization. And if you look through, you can kind of see how the search process goes. You start with database searching. You remove duplicates, obviously. And then you start screening for what's eligible by title and abstract. And then you screen by full text. You can see in the box over to the left that I identified 6 additional sources through gray literature searching, which was our reference list, journal hand searches. And we did all of that to full text screen what would be eligible and ineligible. Again, I'm following the initial Pecos framework that I set up a priori before I got started. You can see that at every step, I'm reporting the numbers for what I found. And in the boxes on the right, I'm reporting what got excluded. And when I get to the full text, I even report why I excluded it, along with the Pecos framework criterion that it did not meet. All of that gets us to the box at the bottom center, which is how many studies we actually got into our review by the end of all of this. It's important to have a document like this. This is what we call a Prisma flowchart. It's important to have this so that we can follow along and know that what's done is transparent and replicable. There are no hidden searches here. There's no man behind the mirror. What we have here is just a clear and transparent methodology of what's been done for the paper. Next slide. Our third step is extracting the relevant data. This, in some ways, is the most difficult part. So I've set up what should be included and excluded. Okay, I can do that. I know what I'm talking about. I've done my search. That was step 2. Okay, I mean, that's a pretty legitimate and manageable task. I list the journals I'm going to search. I list the gray literature methodology. Cool. When we get to extracting the data, things get a little harder. Now, of course, we have a code book that we established a priori at the beginning of our process. Unfortunately, of course, when we started the process, we didn't know everything that we would know. So, for example, we may not have realized that studies would report a certain variable that we found very important, so we need to add it. More often than not, though, we'll also find that primary sources don't report things we really want to know. Anyone who's done a meta-analysis will notice that there are, I mean, it is shocking the quality of primary studies you will find. That they don't report the number of students in each group, or they don't report how many doses each group was exposed to. So you will be surprised and horrified to see what isn't reported. But you should definitely be making a note of that so that you can discuss it in your discussion section and so that you can potentially do some analysis based on that. So we use our code book and we extract the information we need. Next slide, please. When we do that, we focus mainly on the methods and the results sections of the primary studies. So obviously, we're reading the entirety of every article that we include. There are no shortcuts here. But it's important that we focus our attention on the sections that provide us the information that we will actually be extracting. We're not particularly concerned with the discussion section or the introduction or conclusion, because what we really want to get is the raw data from the primary study. So we need to know what the primary study did, method section, and what they found, results section. I will say up front that it is really important that you have a statistical expert in your back pocket, because although you may have taken, as I did, several stats classes and feel totally conversant with stats, you will open a results section of a paper and you will look at it and think, what are these people possibly reporting? And that's when someone like Dr. Emily Tanner-Smith or another expert that you have in your back pocket will be incredibly useful, because they can say, oh, what that is that's an unstandardized correlation coefficient, and this is this, and this is that. And actually, when they report this, what they really mean is that, and kind of walk you through the thornier patches. Now, you're probably going to end up looking at means and standard deviations or regression coefficients. Both of those are pretty easy to work with. That's pretty manageable. You may also get other kind of stranger results. Not that an F-test or a T-test is strange necessarily, but we would actually be using the F-test or the T-test to back into the raw data that undergird those tests. So it's important for us to be thoughtful about what we're extracting. We need to extract sample information, we need to extract results information, and then we also need to extract quality information. Next slide, please. Now we get into the fun part, analyzing your data. The first thing that we do is we summarize our descriptive statistics. Now, in our summary of descriptive statistics, we're going to be looking mostly at the study level data that we have extracted from our primary studies. So those are the characteristics of the studies themselves and the samples within that study. Keep in mind that for a meta-analysis and a systematic review, our unit of analysis is that primary study. So it's important that we are very clear and upfront about the information about those primary studies that we extract. Next slide, please. What you'll see here, and the font's a little small, but you'll be fine, don't worry about it, is the characteristics of the included studies in my meta-analysis. It's important that we give a table like this so that we have the basic information about what was reported and what was not reported. You can see there are many, many NRs throughout this table. Many studies did not think it was important, for example, to report the age of the high school students that they were studying, or the percentage that were male identified, or the percentage that were white, for example. Some didn't even report the percentage that were LGBTQ from their sample. It's important to give the reader a sense of what studies are included in your meta-analysis. It's also important that you are transparent about the types and qualities of these studies. Now, you'll notice that I only list the first author on the left-hand column, just because otherwise formatting gets terrible if you try and list every author. Obviously, every author is deeply important, but we can only list the first author and year. You'll also notice the third column notes the publication format. That gives the reader the idea of whether we're synthesizing mostly journal articles, mostly gray literature, or a mixture. We can also see whether it was peer-reviewed or not, what the population type was, how the sampling methodology was done, what the scope of the sample was, and then the sample characteristics themselves. It's important that we report all of this because we need to show our readers the quality of what was synthesized in order to get our effect sizes. Many people just want to read the results and conclusion, but we need to make sure that we're offering our readers insight into what we actually synthesized together. We don't want to just give them our final synthesized effect size. We want them to understand what went into that effect size. Next slide, please. We continue with our data. So now we have extracted the information that we've needed. We've summarized descriptively our sample data. And now it's time to calculate effect sizes as needed. Now, I say as needed because there will be some situations in which you cannot calculate effect size. It is very likely that some of your studies will not provide sufficient information to calculate a standardized mean difference or to calculate that Pearson's R that you need in order to move forward in your meta-analysis. That is totally fine and understandable. You should note that in your text, of course. And what best practice is you email the author and say, thank you so much for your lovely study. I'm so interested. Your work is so vital and so important, and I would love to include it in my meta-analysis. Please, please, please email me back with the information that I require so that I can, in fact, include it. With the data that you do have that can be converted to effect sizes, I cannot recommend enough Campbell Collaboration's ES Calculator. It's a very simple website, and as you log onto the website, there's the left-hand bar that just gives you all of the different options for effect sizes you want, and then the data that you have. So for example, if you're calculating a standardized mean difference, but you don't have means and standard deviations, you can click on that sidebar, say, okay, I want a standardized mean difference, but all I have is a t-test. You click t-test, and it tells you the data that you need to input in order to get that standardized mean difference. The math behind it that undergirds it is unbelievably complicated, and I certainly do not understand it, and you don't need to either. But if you want to, I obviously empower and encourage you to. But it is incredibly, incredibly useful. It gives you a sense not only of how to calculate effect sizes, it also calculates those effect sizes for you, and it can be used to ground your coding methods. Because if you know, for example, that you can use an F-test and group sizes and degrees of freedom in order to back into a standardized mean difference, you're in a much better place. And you don't have to kind of not include a study because it didn't provide the information you thought you needed. You can potentially back into that information in another way. When you've calculated all of your effect sizes, what you will have is an effect size of interest for each study, and you also have the variance for each study, for each effect size. The Campbell Collaboration ES Calc gives you both. If you are anything like me, you then use software to synthesize these effect sizes together. One could do it by hand, theoretically, and I'm sure in the olden days people by candlelight love to do that kind of thing. That is not my preference, and it does not make any sense to me at all, especially when R has free packages, Meta4, that do a great job doing incredibly robust meta-analyses and that offer just unbelievable options. And Stata, which is not free, but is incredibly user-friendly. And essentially within Stata, what you can do is just import your effect sizes and variances and say, hi there, please run a meta-analysis, and it will run the meta-analysis for you. You obviously have to tell it whether you want to kind of the qualities of or the type of meta-analysis you want to do, but it is unbelievably easy to work through. Now, when we say we input all this into Stata, I want to show you what comes out of Stata. So if we look at the next slide, we can see a sample forest plot. That's kind of the backbone, the meat of most meta-analyses. So here we see a sample forest plot for GSA presence and homophobic victimization. On the left column, we can see the reference, which is just the author and the last name. In the middle, we see a plot of the effect size with the confidence interval kind of stretched around it. So the box is the effect size and the confidence interval are the lines that extend from it. We see a line down the middle. The solid line is 0. If we have a 0 standardized mean difference, what we're saying is that there is 0 difference between the two groups. That means that there is no effect of a GSA. There's no favoring for or against a GSA. So traditionally, if we want a significant finding, and in this world we tend to, we want an effect size with a confidence interval that does not include 0. Sometimes you don't even care which side of the 0 bar it's on, but we want to make sure that we do not cross over 0. All the way on the right side, we can see our effect size and the 95% confidence interval calculated out and provided for you. At the very bottom, we can see the overall effect size with the confidence interval. Now, when we look at the overall effect size, that's the diamond, and the red dotted line is the effect size, and the diamond encompasses the confidence interval. We can look and see that we have found a standardized mean difference of negative 0.19, and we have a confidence interval that does not include 0, which means that we have a statistically significant standardized mean difference that favors GSAs. This is our results section. You've probably seen a forest plot before, and knowing how to read it is, I think, hopefully, very helpful. Next slide, please. The final steps of analyzing the data get into a bit more complicated measurements. So we should examine the heterogeneity in the effect sizes. Just like in a primary study, we would look at the variability of our findings. We also want to look at the variability of our effect sizes. So when we synthesize everything together, how variable are those effect sizes? Moreover, it can be important to conduct subgroup analyses within our effect sizes. So we can examine if effects vary along potentially important lines. For example, no one was probably looking closely enough at the forest plot, which is obviously fine, to notice this, but 6 of the studies were all from the same author. It might be useful to know if that author is skewing the data. So what we can do is do a subgroup analysis and look at that author versus all other authors and see if there's any kind of difference. We could also see if there's a difference along subgroup lines. For example, if the intervention were more effective for male-identified students, female-identified students, or trans students, for example. We might also want to conduct sensitivity analyses. When we conduct sensitivity analyses, we're basically looking to see how robust our findings are along different lines. We've talked a little bit about quality analysis. So if we look at quality analysis, we may want to conduct a sensitivity analysis and say, okay, let's drop out all of the studies that did X poorly. Are our findings still robust? Are they still statistically significant? So we might want to drop out low-quality studies. We might want to drop out studies that measured victimization differently. For example, if 6 of the studies measured victimization over the last year and 3 of them measured them over the last month, we may feel comfortable synthesizing that together because we might think, okay, the month stands in for the year. It's all kind of the same construct. But we may then want to conduct a sensitivity analysis to compare those two. Next slide, please. Step 5, interpreting and situating our findings. So we've now provided our results section. We've given you forest plots. We've talked about heterogeneity. We've talked about subgroup analysis and sensitivity analysis if it's appropriate. And now it's time to interpret and situate our findings. It's super important that we provide the practical significance of the synthesized effect sizes. So many times in meta-analyses, what people will do is just report the effect size, say it's significant, and move on with their lives. Unfortunately, to those of us who live in the real world, we need to know whether that significant difference is actually practically significant and not just statistically significant. So great, you found something statistically significant, but does it result, is it the same as a kid being bullied like 1 minute less a year? That's not something that we're potentially interested in. So it's important that we situate the practical significance of our effect sizes. So for example, with the effect size that I found, students at schools with GSAs reported homophobic victimization at a rate 0.67 that of their peers at schools without GSAs, which is a 33% lower odds. Although that may not be like the least jargony term in the entire world, at least it gives us a better idea of what that means. It's a 33% lower odds of reporting homophobic victimization. Next slide. The next thing we want to do to interpret and situate the findings is compare them to available benchmarks in our field. We do this because it again helps us to know the practical significance of what we found. It's important for us to have an idea of how our synthesized effect size matches up against other data in the world. So for example, what I did in my study, and not that, obviously, sorry, not that my study is like the gold standard for meta-analyses, it's just much easier for me to talk about what I've done than other things. What I did was I looked at other anti-victimization meta-analyses, and I looked at their synthesized effect studies, and I then compared it to what we had found. And I noticed that what we find with the GSA is similar to or larger than the effect sizes of those other studies. So by situating that with other available benchmarks, we get a better idea of how important our findings are. If we're doing something on reading comprehension, for example, we may want to situate our novel meta-analysis of a new intervention with meta-analyses of other interventions that have been done in the past. This reading comprehension intervention increases students' reading comprehension at twice the rate of the others that have been found, for example. Next slide. As with any study, it's important to acknowledge the limitations of your work. Strangely, because a meta-analysis functions on two levels, it's kind of one level removed from primary studies, you actually have limitations on both your own work and the primary studies themselves. So you're going to want to acknowledge, of course, that the primary studies may have weaknesses within them. But you should also acknowledge that your meta-analysis itself had weaknesses within it. So it's important to acknowledge both sets of limitations as you move forward in your limitation section, and don't just kind of say, you know, my meta-analysis was perfect if only these primary studies were better. It's probably a bit more academically humble and appropriate to acknowledge that yes, the primary studies could be more robust, but also there's probably something you overlooked in your meta-analysis. Next slide. I wanted to end, before questions of course, just offering some useful resources that I found over the course of kind of my life with meta-analysis. Meta-analyses are basically impossible to be done alone. We need a team of people and we need a team of resources. So it's really important that you reach out and that you kind of collect whatever information and resources you can possibly find. If your university doesn't offer a course on meta-analysis, never fear. There are tons of YouTube videos far more complete and robust than this one, that will offer you really important insight into how to conduct a meta-analysis. There are some great books. Practical Meta-Analysis and Intro to Meta-Analysis are both really, really awesome and as user-friendly as they possibly can be. You may want to look at the Messier guidelines that are put out by the Cochrane Library. They walk you through what goes into a good meta-analysis. And then if you're thinking about doing meta-analyses in Stata and in R, having a tutorial available to you would probably be helpful. And there are two pretty good ones that I found, and I'm sure that if you Googled around, you would find other additional very helpful resources. I think it's important to think about the fact that none of this is done alone, and although we pretend like we get our dissertations and we get our tenure all on our own, it's all done within a community of scholars and learners, and there are tons of people and resources that you can reach out to, so that's certainly important. Next slide. So thank you very, very much for your time and attention, assuming that you paid attention. And if you put me on mute and watch an episode of The Office in the background, that is also totally fine. We need more people conducting high-quality meta-analyses. We need more people doing this work. It's super important, and please join us, join the community. If you have questions or concerns, feel free to reach out to me, robert.a.marx@vanderbilt.edu. Please feel free to reach out with like the more technical questions. I will certainly forward your email to someone who knows more than I do, because again, I am more concerned with kind of the practical implications of meta-analyses and using them to make decisions and to ground evidentiary support rather than kind of the nuances of the math. So if you have questions about the nuances of the math, I am certainly not your man, but there are tons and tons of people out there who would love nothing more than to talk the math with you. With that, I think I'm ready for questions if we're ready to have them.
That's great. Thanks so much, Robert. This was a really great introduction, and thanks for the step-by-step breakdown. It's really helpful for those of us who aren't as familiar. I have a few questions on deck, but I invite other people to submit questions in the chat box, and we'll put those in the queue as well. There's been some discussion in the chat during the webinar, which is great. I wanted to give Robert an opportunity to weigh in on some of those discussions as well. So there was, nothing crazy. There was a question from William about the process of screening titles and abstracts for relevance and whether that's done manually. And some people jumped in and said, yes, that is done manually, and Lisa suggested using a reference manager makes that a much quicker process. And I was wondering if you had any other strategies that can make that process more manageable for people, or if you could talk about how you go about that.
I would love to. Thank you, William, for the question, and thank you, Lisa, for piping up with a, I'm sure, super good answer. So in terms of title and abstracts, I do everything manually. I also, basically to get a meta-analysis or systematic review published, you need to have independent double coders. So not only do I do it manually, but I recruit someone else to also double screen with me so that my decision isn't the final decision. It is super important to have some kind of reference manager that you're working with. I have worked from everything as kind of rudimentary as just doing it in Excel and having an Excel spreadsheet for myself and an Excel spreadsheet for my double coder, and just inputting all of the titles and abstracts, giving everything a study ID because otherwise you're going to be totally skewed and won't know what's what, and then having a column that's just a 0 or a 1, 0 for excluded, 1 for included for title and abstract. And then what I tend to do for double coding is anything that got a 1 from me or a 1 from my double coder, so anything that seemed like it could be included by either of us, then gets full text screened. So you retrieve the full text. I normally create a second Excel spreadsheet and then use that. Now, there are reference managers you can use. I've done it with EndNote Online. I've also done it with FileMaker. So there are different options for you. Honestly, it depends on how much money you want to invest in the project, how much resources you have available to you, and how large you think your search is going to be. For the GSA search, if you're only looking at 750 titles and abstracts, you can do that in an Excel spreadsheet. It's probably not worth the time setting up a FileMaker database to do that. However, if it's going to be something super robust and you've got 30,000 studies that you're screening, which sounds like a nightmare, and I would think about my search strategy, you can definitely look into a more thorough reference managing option. I hope that answered that question.
That's great. Thank you.
Yeah, you're welcome. Thank you.
The next question is from Stephen. And again, some people chimed in the chat, but also wanted to give you a chance to answer so that everyone can hear your thoughts. There was a question about differentiating reviews and meta-analyses and whether effect
great
sizes,
question.
Yeah, and specifically whether effect sizes are typically reserved for meta-analyses.
That is a super, was that Stephen?
Yeah.
Super good question, Stephen. So I said that this was going to be an introduction to systematic reviews and meta-analyses, and then for probably 40 minutes just said the word meta-analysis over and over and over again. So if you just logged in for systematic reviews, I apologize for giving you short shrift, and you probably zoned out and got bored. So when we think about systematic reviews, we think about them as the foundation for meta-analysis. So we think about them as giving us all of the information that then might be synthesized into a meta-analysis. Now, systematic reviews can include both quantitative and qualitative data, whereas meta-analyses are only going to include quantitative data for the most part. When we think about effect sizes, we're only thinking about quantitative data. Meta-analyses need to have effect sizes, otherwise you have nothing to synthesize together. However, a systematic review could also have effect sizes. It's just that you couldn't synthesize those effect sizes together. So for example, I have another not interesting, please don't read it, meta-analysis in the works. It's on later school start time. And it was supposed to be a systematic review and then a robust meta-analysis. Unfortunately, because of the differences in operationalization, study design, construct development, and measurement, it basically just became a systematic review. I calculated effect sizes for all of the included studies that I could, but because they were so different, I didn't synthesize them together, and so it wasn't a meta-analysis. So when possible, you should be calculating effect sizes, either in a systematic review or a meta-analysis. And then when possible, you should be synthesizing those together into a meta-analysis if you can and if it's appropriate. But effect sizes may be in a systematic review as well.
Great, thank you.
Of course.
The next question is from Brant about P-curve analyses and whether you, what's your view on whether those should be included, and maybe we could just give a brief recap of what a P-curve analysis is as well for anyone who's not familiar.
So I would love to kind of, this is terrible, I'm going to take a pass on this question. P-value stuff is really misunderstood by both the scientific community and the very handsome and smart Robert Marx. And so I think that we would get muddy enough just talking about p-values and whether we should be talking about p-values or confidence intervals and whether we should be doing null hypothesis testing in the first place. And I think that there are much more qualified people who should be talking about this, and that person is not me. And so I would love to direct Brant and others to kind of Googling around that and reading textbooks around that and not being subjective to my kind of random rambling trying to piece together an answer to that question, if that's okay.
Sounds great. Okay, the next question is from Catherine. And
Hi,
Catherine was wondering if there are any strategies for combining effect sizes from between subjects and within subjects designs.
That is a great question. And so there are a number of different ways we can approach that. I think it really depends on whether the effect sizes should be synthesized together. So whether the construct that's being measured is similar enough that it makes sense to synthesize, and whether the study design makes sense to synthesize together. In most cases, honestly, you're probably better off pooling your withins and pooling your betweens and doing it separately in two different meta-analyses, because oftentimes you're going to find that you can mathematically make it go, but what you get from the end of it isn't what you wanted in the first place, and the similarities aren't strong enough that you should have meta-analyzed it in the first place.
Great, that makes sense. Thank you. And we've got one last question, also from Catherine. And Catherine was wondering whether it's still debated.
Catherine sounds smarter than me. Catherine should have been doing this, but that's okay.
Catherine was wondering whether it's still debated whether or not to include non-peer-reviewed studies in a meta-analysis. She's read some reviews where they choose to only include peer-reviewed studies. So is that still kind of a debate within the field?
That is such a good question, Catherine. And it gets to, I mean, I feel like I'm going to get climate changey in a second, but it gets to what you mean about the word debate, I guess. The vanguards of what good systematic review and meta-analysis are have made it very, very clear that we need the broadest and most comprehensive evidence base possible, and that means including unpublished, non-peer-reviewed studies. However, Catherine is 100% right that if you did a quick search right now for meta-analyses, you will find tons and tons and tons of published, peer-reviewed, often cited meta-analyses that do exclusions based on publication status or peer review, which is a no-no, which do exclusions based on language, which is a no-no, which do exclusions based on arbitrary dates, which is a no-no. So the answer is, the debate has been settled, and yet people still don't conform to the recommendations that have been made. And interestingly, some of my more recent work focuses on reviews of reviews, or meta-analyses. So it's looking at synthesizing across metas together, which is like it turtles all the way down, gets a little spirally. But suffice it to say, when we quality analyze or quality code meta-analyses and systematic reviews, it is a ding against them if they only search published literature. So it is thought of as a risk of bias for that meta-analysis if it only includes published literature. And although I'm sure that there is someone listening and people in the world who would vociferously debate that we should only be using peer-reviewed sources and that's the best evidence possible, in my mind, that reflects kind of a myopic view of what peer review means and what evidence means. Because I've been through peer review processes that were not rigorous in any way, shape, or form. And we all know that statistically significant results are more likely to get published in the first place. So I would say, Catherine, fight the good fight. Do not include limitation characteristics along publication status. And if, and I think this is a totally reasonable if you get pushback, or even if you don't get pushback, you can always, always, always do subgroup analysis and compare by publication status. And it'll get too technical, but you could do a meta-regression and compare the differences for published versus unpublished studies if somebody says, oh, well, your results were only that way because you included all this junk. You can show them what it would be if you only included their golden, beautiful, peer-reviewed studies. Sorry for that rant.
Great, thank you very much. And Catherine said thank you in the chat as well.
Oh, great, Catherine, you're more than welcome.
So I just want to say a big thank you to Robert for this very informative and engaging introduction to meta-analysis, and also want to thank all of you who attended today. Wanted to say a special thanks to Sarah Mancall, SPSSI's Policy Director, who's coordinating today, and to Cindy Lucas, who's also helped to promote the webinar as well. And as a reminder, today's webinar was recorded, and we'll be sending out the link to the YouTube recording and today's slides via email to any registered attendees. And you can also find the recording on SPSSI's YouTube channel. And with that, I'll turn it over to Sarah for any final comments.
Thank you. I learned so much today. So if you'd like to learn more about becoming a SPSSI member, I have the link listed here on the last slide. And I also want to let you all know about our next webinar, which is going to be on June 6th at 1 p.m. Eastern. It is another methodology-focused webinar, and it's on measuring and assessing constructs, exploratory factor analysis, confirmatory factor analysis, and average variance extracted. So I'll send the slides around in a very short time, and please register for that and share it with friends and colleagues if the topic interests you. And thank you so much for joining us today.